we're going to start checking the problems on 7-1. So first of all, let me know if you have questions about any of those problems. Is there anything you want me to go over from the first one there? Okay. Here's the bottom of that page. Okay, about these. So would you like me to walk through any of the conversion problems? Any questions on anything? So I see a couple of examples. So you really don't care which one you want or one's where? You don't really care which ones? Yeah. Okay, so like, for example, when you start this one, since you're doing 2 quarts to 4 gallons, you need the conversion between quarts and gallons. Since there's 4 quarts in 1 gallon, that means you're going to make a ratio that's equal to 1 by either putting gallons over quarts or quarts over gallons. Since you want the quarts to cancel and the gallons to cancel, it means we want the quarts on the bottom and the gallons on the top. But that's supposed to equal 1. So 1 gallon and 4 quarts are the same. That means this will equal 1. And then when you simplify, your gallons will drop out and your quarts will drop out. Again, remember, you're multiplying straight across. Okay, and then that's 2 over 16 or 1 over 8. Okay, if you want to simplify back here, you can do 2 divided by 4 is 1/2 and then do the multiplication. So you're allowed to divide numbers also. I would just caution you against doing too many things at one time. Okay, but when you start these, you need to make sure that you know what the conversion factor is. So one more of those. If let's do this one. So 16 ounces in 1 pound. So we got 24 ounces over 2 pounds. Okay, there's 16 ounces in 1 pound. So if you put 16 ounces over 1 pound, that'll be equal to 1. And if you put 1 pound over 16 ounces, that's also equal to 1. So the way you decide which way to do it is you want ounces to cancel with ounces, you want pounds to cancel with pounds. So since 16 ounces is 1 pound, when you multiply, again, you're going straight across. So pounds will cancel, ounces will cancel. You'll have 24 over 32. You can divide out an 8, right? We'll make it 3 over 4. Now, if you prefer, you can also do this by saying, okay, 1 pound is 16 ounces. So in place of pound here, I'm going to put 16 ounces. And then when you multiply, you'll get 24 ounces over 32 ounces. So it would look like this, except that it'll have ounces on there and then you cancel those at the end. If you would rather do kind of a substitution thing, since 1 pound is equal to 16 ounces, you can replace pounds with 16 ounces. Okay, what about on the simplify? Do you have any issues with the simplify problems? I know I did a couple of those kind of quickly last time. Do you want to work through any of those, either of those? No? You're not going to talk to me? Any questions on those? Yes. This number 8. Okay. So a yard is 3 feet. So when you multiply it straight across, it's going to be 14 over 18 and then divide out of 2. Okay. So again, we're using 1 yard equals 3 feet. So when you do the multiplication, you're putting yards on top so that yards will cancel. You're putting feet on the bottom so feet will cancel. Just multiply straight across and simplify the fraction. Grace. This one.
I thought that you said that you could like dividing within the square root. I thought you said you had to keep it, you could simplify the square root like inside the square root.
Okay, so when you go to divide a 5 here, you're going to be stuck because there's no number outside here, which means it's a 1, and there's not a factor of 5 that will come out of 1. But you do need to simplify that first. And then after you simplify it, then you'll have a number on the outside. So yeah, I said you have to, if you're going to divide something out of the denominator, it has to come out of all the numbers in the one in the front of the radical. Okay, but for this one, square root of 75 is not simplified. So here is 75 is 3 and 25, and 25 is a perfect square. So the 5 will come to the outside, and there's a radical 3 inside, and then you can look at all of the values. So you can divide out of here, here, and here. So when you take out of 5, it doesn't affect the square root of 3, and you're not allowed to divide out of 5 here because you would only be able to take it out of these numbers, and you're not allowed to do anything with the 75 because it's underneath the radical. So you simplify it, and then you're able to do a little canceling. Here's the first quadratic formula. So if you did not get 1 plus or minus root 5, you want to first look and see if you have the right equation. So check this equation right here. And then notice I divided a 4 out to make those numbers smaller to work with a little more easily. So if you have something different down here, it may be because you didn't divide out the 4. But in the end, even if you didn't divide out the 4, it should work out to be the same. Okay, when you get down to the bottom here, this is like the one that Grace just asked about. You get a square root of 20, but you need to simplify that down, and then you're able to divide out of here, here, and here. If you wrote this like this, 1 plus or minus root 5, you can write like 1 plus or minus 1 root 5, or 1 plus or minus 1 root 5 over 1. You don't have to have the 1 here or here, but you have to have the 1 in the front. Okay, if there was no 1 there, it would be understood to be a 0, which it is not. It should be a 1. Questions on that one? I'm sorry. Yeah, what do you want to see? The one to the right? All of them. Okay, for the second quadratic formula problem, did you remember you have to FOIL when you have 2 binomials you're multiplying? So it should be when you multiply the 2x plus 3 and the x minus 1, those need to get FOILed out. Okay, so 2x plus 3 times x minus 1 means you distribute. And we'll do 2x times 1x is 2x squared. 2x times negative 1 is negative 2x. 3x here and negative 3 there. So when you get it solved for 0, this is what your equation should be. If you did not FOIL on that, then of course your answer is going to be different than mine because you're not going to have the same equation. Okay. I'm sorry, you want me to zoom in or out? I didn't hear you better. You want to see this one? Okay. Okay, guys, you can take pictures of that if you need to. I'm okay with that since you turned it in. So again, this one's tricky because when you do this product, you actually have to do the distributing. So there's 4 terms here that will simplify down to your trinomial. That did not happen on the other problem, so that makes this one a little more complicated. In the end, again, make sure that you realize 169 is a perfect square, and then you actually do the plus and the minus and get your 2 rational numbers there. So don't stop at -1 plus or minus 13 over 4, because you're able to actually add and subtract -1 with 13. If that was a square root of 13, you would just leave it. But because the radical disappeared, since this is a perfect square, that means you're able to simplify. Any questions on that one? Okay, here's the 2 at the bottom. This one actually was also, that would have been factorable. You can tell that by the answers that we got there. So if you factored this, you'd have 2x times x. And then to get -21, what numbers do you think we're going to use there? We want a plus 1x with a product being -21. So the numbers here have to multiply to -21. And when you add those, they should add to +1. We already know the answers, right? The answers are 3 and -7/2. That should help you. If x equals 3 is a solution, what is one of those factors going to have to be? Like if it factored down to be x plus 5, and something. That would tell you x equals -5, right? So if we got x equals 3, what is one of the factors? I mean, like x plus something, x minus something. What is this factor right here going to have to be? A plus or a minus? What does that have to be if it gives you x equals 3? -3. Yeah. So it must be -3 and 7. What should the sign be for trying to get -21? Yeah, it's going to be +7, right? So if you FOIL that out, and again, I'm doing that because we already know the solutions. Obviously, if you didn't know the solutions, you have to do guess and check to get it to work. Okay, but that would give you your -7/2 and your x equals 3. Now, I asked you the quadratic formula on that, but you would also have been able to factor that, because that one is factorable. Okay, these I said solve by factoring. All of this algebra stuff, we're trying to, again, kind of keep your skills fresh and boost some of those skills that maybe were never quite as strong as they should have been, or that you need to be reminded of. So, like Diamond asked the other day, does factoring ever go away? No, it doesn't. You actually do more kinds of factoring algebra too than you already know. Questions on any of those problems? Okay, we're going to go ahead and get lesson 7.2. So 7.1 was solving proportions. 7.2, we're going to start talking about similarity. All right, so go to today's folder and import lesson 7.2. Your homework is going to have 7.2 stuff and then also some more quadratic formula practice. All right, so we talked about similarity before. When we had a problem like this. Are those triangles congruent? Are those triangles congruent? What are the ways to prove triangles congruent? Peter? Side angle side was one. Kara? Yeah, so that's like Kara, another one. Angle, side angle. There's one more. Hypotenuse leg works for right triangles. So that's kind of like a special one. There's one more that works in general for triangles. What's the last one? Angle, angle, side. Good. So when I gave you that information on that's shown on the triangles there, is that going to satisfy any of these ways of proving triangles congruent? No, because you don't have any side lengths. So we talked about how when you're trying to prove congruence, you really cannot just use angles alone, because it may be the case that the angle measures are the same, but the sides are not congruent pairwise. So that angle stays the same, that angle stays the same, that angle stays the same. However, the sides are not pairwise congruent. Okay, what they are is called proportional. So if this is like, let's go like 10 and 5, that means that all of the side lengths should be in what ratio? When you compare the sides here to the sides here, the ratio should always be 2 to 1. Okay, so let's say this is like 12. That would make this one have to be 6. And if this one was 7, that would make this one have to be 14. Not drawn to scale because it appears as though the 12 side is longer than the 14, so don't worry about that. But you would know that these angles here are also congruent, but angles alone are not sufficient, okay? These triangles would be similar. Angles alone don't make congruent triangles. Okay, so we talked about similarity a little bit before because of the fact that when we were trying to determine if triangles were congruent, we discussed how angle is not going to work. Okay, so the definition of similarity. 2 triangles, 2 polygons are similar if and only if all of their corresponding angles are, how should the angle measures be related? All the corresponding angle measures should be what? Congruent, yeah. So all the corresponding angle measures are congruent, but the side lengths will be proportional. Now, again, what that means is that when you compare all the corresponding side lengths, you should get the same ratio every time. Proportional. We say the shapes are similar, the sides are proportional. So it's kind of a common mistake for students to call sides similar. Sides are proportional, angles are congruent. Okay, that's the definition of similarity. So the idea of, congruence means same size and shape. The idea of similarity is that they have the same shape, but they might be different sizes. Okay, similar means same shape, possibly different sizes. Now, why am I saying possibly different sizes? Well, let's say you do have 2 congruent polygons. Would they be similar? If 2 polygons are congruent, are they also similar? 2 polygons are congruent, are they also similar? Grace? Yes. Okay, so if you compare, if you have 2 triangles or 2 polygons, whatever they are, I'm going to copy this over. Congruence is actually stronger than similarity, right? So if I have these 2 triangles and they share the same angle measures, right? All the angles would have to be congruent because I've drawn them to be congruent triangles. And all the side lengths pairwise have to match up. Okay, so the question is, are they similar? So similarity means the angle measures have to match up to be congruent, the side lengths have to match up to be proportional. Well, we know the angles match up to be congruent, they're obviously the same. Is it true that when you compare a side length here to a side length here, what's that ratio going to be, first of all? It's what? It's 1 to 1, right? So those two would have to be 1 to 1. What would this ratio be? 1 to 1. What's this ratio? 1 to 1. So they're similar because they do have all the same angle measures, and then their side lengths are also proportional. So these are congruent, and they are also similar. Okay, so are congruent polygons similar? So we're checking the definition. Yes, they're always going to be similar because congruent polygons have all corresponding angles congruent and all corresponding sides. What's the word again that means that they have a common ratio? Proportional. And again, the ratio would be 1 to 1 because they're congruent. It'd be like 5 to 5 or 10 to 10 or 27 to 27 or whatever. Okay, will similar polygons always be congruent? So congruent polygons are always similar. Are similar polygons always going to be congruent? No. Can they be? Yeah, they could be, but generally they're not. Similarity is not as strong as congruence, right? Again, similarity means they have to have the same shape, but one could be larger or smaller than the other one. They could be the same, but they don't have to be the same. Okay, notation for similar is a little tilde. So just like we use the tilde with the equal sign for congruence, this little tilde by itself is the symbol for being similar. Okay, and then next idea is what's called scale factor. Scale factor is the ratio you get when you compare corresponding sides. So if I was looking at this triangle up here, this set of triangles up here that I drew, move these guys over a little bit. If I was looking at these triangles here that I drew, what would be the scale factor from the left one to the right one? What is the scale factor from the left to the right? So if you compare a side here to a corresponding side here, what is that ratio? 2 to 1. Now you can either write it with the colon form like that, or else you can put it as a fraction, okay? But scale factor just means when you compare all the corresponding sides, it's the common ratio. If the shapes are similar, there should always be a common ratio. And then the other thing, before we actually jump into problems here, is that the order matters when you write the similarity statement, just like with congruence. So if you were to draw, if it says, jump down here, it says the order of the vertices, if the vertices are put in a certain order in a similarity statement, that means that's how they match up. So if I tell you A, B, C, D is similar to W, X, Y, Z, that means you know that when you draw A, B, C, D, actually I'll make that one look like it's bigger. Okay, when I label this A, B, C, D, that means I'm telling you that A has to go with W and B has to go with X and C has to go with Y. Get all those in there. That's Y. I need to go a little skinnier, sorry. Let me see what I'm doing. 1, 2, 3, 1, 2, 3. C and Y match up, and then D is going to match up with W. So that's called a similarity statement, just like we wrote congruent statements. This is called a similarity statement. What? I put 2 W's, I'm sorry. That is Z. That's called a similarity statement. So if I told you that this was 21 and this was 35, what would be the scale factor? What would be the scale factor? Brian, tell me the scale factor. So on this one, the scale factor was 2 to 1. Right? This one, it would be what? Just compare the corresponding sides. It's a fraction, so it's 21 to 35. And then what does that reduce to? Ryan, what can you divide out of the top and the bottom? So 3 over 5. Scale factors we always want to give as a simplified fraction. If you want to write it like 3 to 5 like that is perfectly fine. Just make sure that you have it simplified. Sometimes it's harder to see that it's not simplified when it's not written as a fraction. So just be careful that you always simplify your scale factors. Okay. Again, scale factor is simply the ratio of corresponding sides. Let me pause for a second. Okay, so if we have similar shapes, which we know we do because they're telling us here how everything matches up. Okay, we can see how things match up because of the fact that R and X are marked to be congruent, right? And S and Y are marked to be congruent with 2 marks, and etc. Now I'm going to go ahead and match up the sides by, you can either use colors or you can kind of indicate it on the picture. Oops. So segment RS is going to match with segment XY. Okay, so RS is matching with XY. That's here. You don't want to put marks on it like that because that means they're congruent, right? We're not saying they're congruent, we're just saying they correspond. If you want to use colors and just go like, that and match them up like that, you can do it. That it's just that when you're on a quiz or a test where you're not using a highlighter type tool, it's going to make it a little more difficult. Okay, what does 12 correspond to? Which side does the 12 correspond to? X, Z, this one? Oops, sorry. This one, how do you know? Okay, so you can either look at the similarity statement and say RT has to go with XZ, or you can also look at the angle measures, right? This is across from the double marked angle. So that means it should correspond to the ones across from the double marked angle in the other triangle. Or you can look and say, okay, it's the one that's in between the single and the triple marked angles. So same thing over here between the single and the triple marked angles is going to be that side. Okay, and then our last one, 16, is going to have to go with X. You can put a triangle around it or whatever shape you want, but it'll just help if you kind of match them up to start with. Okay, scale factor of RST to XYZ. What number are we going to have to use in RST? Because we only have one side that we actually know, right? In the other triangle. So which side length is that going to get compared with? The 20. Okay, now see how it says the scale factor of RST to XYZ? That means you're going to give the RST length first, and then the other triangle's corresponding side length. Kendall, how does that simplify? 4/3. Okay, which shape is bigger? The first one or the second one? The first one, right? Why does that make sense with what the scale factor is? How can you tell by looking at the scale factor that the first shape is bigger than the second shape? A little bit louder, Kara. The numerator is bigger, right? It's improper. So if the first number is bigger, and again, if you want to write it this way, you can. If the first number is bigger, that means that the first polygon is larger than the second polygon. Okay, but you're always going to make sure you follow the order there. That means if I ask you for XYZ to RST, you would see the scale factor as what? 3/4. Okay, you're just comparing them in the opposite way. So you either say 3/4 or you say 3/4. But the numerator is going to correspond to the first shape that's listed, and then the denominator will correspond to the second shape. If it doesn't give you an order like that, it just says what's the scale factor, your default is left to right. So if I just say what's the scale factor of that and I don't give you a similarity statement, you're going to do the 20/15 one. Okay, you always go from left to right if it doesn't specify the order. So like up here, when I said what's the scale factor and I said 2:1, that's because I'm going from left to right. So if I said what's the scale factor of this one to this one, then you would, do the other order. But if I just say a generic what's the scale factor, you go from left to right. Okay, make a proportion to find the value of x. So x corresponds, little cloud there is where x is. Now we know that our scale factor is supposed to be and it doesn't really matter which one you use, whether you use 4/3 or 3/4, but we know that when we go from the left to the right, it needs to be a 4:3 ratio. Okay, and if we're trying to find x, then we're using 16. Where does the 16 go if I use 4/3? Top or bottom? On the top. Okay. So if it's easier for you to not have it simplified, if it's easier to look at that and go 20:15 as 16 is to x, okay, that's fine. But notice if you've already done the work here to simplify it, it's easier to just call that 4/3. And I know a lot of you are going to be fine with that. If you already have the simplified scale factor, then just use that value. Okay. When you cross multiply that, you'll have 4x equals 48 and x. So x is 12. So that means this length here must be 12. Okay, and if I wanted to find the side length on that one, what would be the proportion? Let me call that like y or something here. What would be a proportion to find y? Grace, can you give me a proportion to find y? The finding x? Is that what you mean? X equals 12?
Yeah.
Okay, so 20 is to 15. Let me do this. 20 is to 15 as 16 is to x. So if you wanted to find y, you could do 20 is to 15 as what? Okay, you want to make sure you're going from this one to this one if we do 20/15. So if we say 20 is to 15 as you want to start, I'm going to use y. What's the side that corresponds to y over here? Give me a number, 12 or 16?
Oh,
12. Okay, so these are the ones that correspond, right? So if I go 20 to 15, then is it 12 over y or y over 12? Which one corresponds to 20? This triangle has 20, right? So use that triangle on the numerator on the other side, and it'll be, no, it's still 12. The 12's on the top, though. 12 will be on the top, not on the bottom. Okay, and it didn't ask you to solve that, but you could then cross multiply and solve to find y. Okay, write a proportion that relates to corresponding sides. That just means list something like RS compared to XY should be the same ratio as what? So I'm just looking at the similarity statement here. Okay, RS compares to XY. Give me another comparison. ST to what? ST to YZ, yep. And then same, what's the last one gonna be? TR to ZX. So notice that Sam went from T back to R. That's okay as long as you go in the same order like he did, okay? If you said RT there, then you would say XZ. Again, order matters just like it did with congruence. You want to make sure that the vertices that match up are in the right places. Okay, that's a proportion that relates to corresponding sides. All of those ratios would be equal to 4/3, right? Because every side in the first triangle compared to the second triangle is a 4:3 ratio. So if your top triangle is the RST triangle and your bottom triangle is the XYZ triangle, all of these would be equal to 4/3. What's 4/3 called again? 4/3 is the what? Scale factor. Scale factor. Okay. Determine whether these figures are similar. So first of all, we know that all the corresponding angles are congruent. So that's good. The second thing we have to check is are all the corresponding sides proportional? So a way to check, there's kind of two ways you can check, well, kind of three ways you can check proportionality. When there's four sides like that, you can do this for triangles too, but when there's four sides like that, I usually will do, to check if the sides are proportional, I'll go 9 to 12 to 15 to 18. Okay, that's a ratio that has four numbers in it instead of just two. And I'm going from smallest to biggest. It doesn't matter if you go biggest to smallest, smallest to biggest, how you match them up, as long as the left side and the right side correspond. I want to know if that's the same as 6 to 8 to 10 to 12. Again, I'm going smallest to biggest. Make sure the left and the right side correspond. What is the GCF on the left side that we could divide out? What can you take out on the left side? 3. Okay, divide everything by 3. What will the left side be when you divide out the 3? Sarah, what would that be when you take a 3 out of everything? No, just divide it out. So divide by 3, just divide it out every time. This will be 3, right? What's 12 divided by 3? 4, and then 5, and then 6. Okay, what can we divide out on the right side? Gabe, what's the GCF over here? Okay, so take out a 2. What is the right side giving you? They're the same. Okay, that means that the sides are proportional. That's a quick way to check proportionality with kind of one condensed proportion. Now, the other thing you can do is you can check all of the corresponding side pairs. I think that this is more efficient, but if you want, you can do, let's see, the short side has to go with the short side. Sometimes they'll be twisted where it's not as obvious, right? But the short sides have to go together. So if I compare 9 to 6, what is that value? 3 to 2. Okay, if I compare 12 to 8, take out a 4, 3 to 2. Okay, if I compare 18 and 12, take out a 6, it'll be 3 to 2. Okay, and then if we compare 15 and 10, take out a 5, it'll be 3 to 2. That's a different way of showing that all the sides are proportional, but that also tells you all the sides are proportional. What is the scale factor? And again, if I don't specify which way, you go left to right. What is the scale factor? 3 to 2. Okay, so what we're doing is we're kind of checking if there is a common ratio, which means that would be your scale factor. Your scale factor would be 3 to 2. Do you see on the, if you do it this way, do you see what your scale factor, where it comes from? It's what you divided out, right? 3 over 2, that's your scale factor. So those are two ways you can check the proportionality. Sometimes students will kind of look at them individually. If you want to know if 9/6 is the same thing as 12/8, so like if I want to check whether 9 to 6 is the same thing as 12 over 8, how do you know if those are the same ratio? There's two ways to know. How do you know if those are the same ratio? When you cross multiply, what should happen? They're equal. Okay. Your other option is just to simplify them, right? This is the same thing as 3/2, and this is the same thing as 3/2. But if you want to go through and set up a bunch of proportions like this to figure out if the shapes are similar, to find if the sides are proportional, you got to make sure you do it on all the sides. That's why I think it's better to do it this way, because then you don't have to go, okay, this to this equals this to this, check that. All right, now this to this equals that to that, check that. Like you have to go through and check like all of the proportions if you do it that way. Okay, how about the next one? So it says these triangles are similar, find the value of x. So how did the sides correspond? So notice where the 40-degree angle is here. The 40-degree angle there and the 40-degree angle there. Okay, and you got a single and a double marked angle. Diamond, tell me how the sides correspond. Which side in the other triangle goes with the 6? Okay, how do you know? Okay, so be careful that you don't assume it's not always going to be drawn to scale. So you want to make sure you look at things like, well, 6 is across from the double marked angle, and that means that across the double marked angle over here should be the same. Or you can say that 6 is between the 40 degrees and the single marked angle. So that means it's going to correspond to over here between the 40 degrees and the single marked angle. Okay, so just be careful that you don't assume it's necessarily drawn to scale. Sometimes you are able to kind of flip it around in your head and figure out how they match, but it's good for you to always look for the markings on the picture. Okay, and then 12 is across from which angle? It's across from, yeah, it's across from the 40. So over here, it'll also be across from the 40. Okay, so where the 40-degree angle is, across the triangle, and those will have to match up. Okay, so find the value of x. I need a proportion. So if I do 6 over x minus 3, what would be the right side of the proportion? 6 over x minus 3 equals what? Braden, tell me what that should be. Okay, if you go from this triangle to that triangle, you got to follow the same order on the other side here.
Can't you say 12 is equal to 6 or 12 over 6 plus or x plus 1?
12 over x plus 1. So you're going from the 6 to the x minus 3. Then you would want to be going from the 12 to the x plus 1. How about a different proportion that would still work? What if you did x plus 1 over 12? If you want x plus 1 over 12, Lily, tell me what the other side would have to say. X minus 3 over 6. Okay, you can also compare within one triangle. If you did 12 to 6, if you did 12 is to 6, as what would the right side be? Is it x plus 1 on the top or x minus 3 on the top? X plus 1. I'll do purple to blue, so that would also be purple to blue. Now, you can do, all of those are the same. How do we know they're the same? Because when you cross multiply, you get 6 times x plus 1 equals other thing. 6 times x plus 1 equals other thing. 6 times x plus 1 equals the other cross product. Okay, all of those are saying the same thing. To solve that, it might be a little simpler to do this one just because that's a 2-to-1 ratio. Okay, you can always simplify on one side of the equation like that. So when you cross multiply, what will this cross product be? Blair, what is that when you cross multiply? Equals. And that would give you x equals 7. All right, and so if you go and plug that back in, x being 7 would make this side 8, and x being 7 would make that side 4. Again, that's good because this is a 2-to-1 ratio. So that means this should be a 2-to-1 ratio. Okay, now again, this scale factor compares corresponding sides in the 2 different shapes. So the scale factor on this one would not be 6 to 12 or 12 to 6. What would the scale factor be? I subtracted 1 and subtracted 1x and added 6. When you add 6, you'll make it 7. Okay, 6x plus 6 and 12x minus 36. 6x equals 42. X equals 7. It should be the same thing. Okay. All right, and then real quick, the scale factor would be 6 compared to what? 6 compared to what? 4. So it would be 3/2. That should be the same thing you get when you do 12 to 8.